Let's solve this challenging implicit differentiation problem step by step. Our goal is to find dy dx for the equation, where cosine x raised to the y power equals sine y raised to the x power. The first step is to take the natural logarithm of both sides. This will help us deal with the exponents. When we take ln of both sides, we get ln of cosine x to the y equals ln of sine y to the x. Next, we'll use the logarithm property that states ln of a to the b equals b times ln of a. This gives us y ln of cosine x equals x ln of sine y. Now comes the challenging part, implicit differentiation. We need to differentiate both sides with respect to x. On the left side, we use the product rule since we have y times ln of cosine x. On the right side, we have x times ln of sine y. And remember, y is a function of x. Let's group all terms with dy dx on one side of the equation. Moving terms around, we get dy dx times the quantity ln cosine x minus x cotangent y equals ln sine y plus y tangent x. Finally, we can solve for dy dx by dividing both sides by the coefficient of dy dx. This gives us our final answer. Dy dx equals ln sine y plus y tangent x, all divided by ln cosine x minus x cotangent y. And there we have it. We've found dy dx through careful application of logarithmic differentiation and implicit differentiation. This technique is particularly useful when dealing with equations involving exponents.